All right, today we are going to be solving and graphing linear inequalities. So to get into that, I need to start you off with a quick review. If I asked you to read the sentence below, or the sentences below, you would read it as Joe jumped into the pool, Sarah ate a ham sandwich. From which direction did you read? You read from left to right. Math is a sentence. We are going to read our statements from left to right. That being said, what would this symbol say? If I'm reading from this side here to this side here, then I should know this symbol says greater than. What would this symbol say? Well, if I'm reading from here over, I know it's less than. What do you see different about these symbols? Here you should see that these two symbols appear to have part of an equal sign attached to it, whereas you would read it as greater than or equal to or less than or equal to. Let's get started. When you are graphing inequalities, there is a way to notate such by use of our symbols with our circles. All right, we're going to use a closed dot for greater than or equal to or less than or equal to symbols. And we're going to use an open dot for greater than or less than symbols. So just recall, greater than or equal to, less than or equal to mean the value can be included. It can be equal to. So we fill in our circle to show that that value is included. Greater than or less than values means your number cannot be included. So we leave it open. Interval notation. This is where we are going to write the notation for our solution, our graph, using infinity symbols, parentheses, and brackets. We use the parentheses for whenever we have open circles. So if you have greater than, less than, open circle, it will be a parenthesis. Brackets are used when our value is included. So if you have a symbol that shows to be greater than or equal to, less than or equal to, and if your circle is closed, it will be a bracket. Let's practice just that. Look at your inequality here. If you read this from left to right, you would read that x is greater than or equal to 8. What that looks like is a symbol with a line, meaning I'm going to have a closed circle, and then if it's greater than, it's going to go to the right. So just write your number 8 on your number line, and you're going to give me a closed circle to show that the value is included. Since it's greater than, we're going to shade going this way. The interval notation. So remember, we read from left to right. Interval notation must match what we see on our graph. If you start on this side of our graph, on our number line, you have a closed circle. Closed circles are notated with brackets. On this side of our graph, we notice it goes forever and ever. That means it's going forever to positive infinity. Infinity signs are used with parentheses. And I forgot to write that up here. Whenever you have an infinity symbol, whether it's positive or negative, we always use parentheses. So I'm going to write my interval notation like this. Bracket 8, comma, infinity sign with a parenthesis. And the order matters. Just like we read from left to right, you have to write your interval notation from left to right. So that means the 8 has to be on this side with the bracket, and the infinity symbol has to be on this side with the parenthesis. You cannot switch it around. Number 2. Number 2 says that a is less than negative 1. Okay, well, if a is less than negative 1, that means my circle is going to be open because it's not included. Less than means it cannot be negative 1. Less than also means that it's going to be going to the left. So for my interval notation, it has to match my graph. I notice that on the left side of my graph, I am going forever into negative infinity. So that means I'm going to have a negative infinity with a parenthesis. On this side of my graph, it's an open circle that also has a parenthesis. So I'm going to write my interval notation in proper order from negative infinity to negative 1. Both sides will have parentheses. At this point, I must say, some of my students have always said the way they can remember which way to shade on their graph is based on the inequality symbol. So if the inequality symbol was pointed this way, they know that they would shade going that way of the pointer. Okay. And then they said if the inequality symbol was going this way, they know that they would shade that way. Well, that actually works, but it only works if your variable is on the left side. So if you write your variable on the opposite side, this little shortcut will not work. If we were to actually solve an inequality, solving an inequality would be the same as what we would do when we solve an equation, with there being one difference. When you solve an inequality, you have to flip your inequality symbol if you multiply or divide by a negative number. The reason for that I like to explain is quite simple. If I give you an inequality statement that is true, such as 5 is greater than 1, you would tell me that that's a true statement. But if I took both of these numbers and divided them by negative 1, you would have negative 5 is greater than negative 1. Is that true? Well, no, it's not true. It would only be true if you flipped your inequality symbol. So if you ever multiply or divide by a negative, your symbol has to flip around, okay? Let's practice. Number 3. We want to solve, and then we want to graph, and then we want to write our answer to each inequality in interval notation. So let's first start by solving. To solve your inequality, we solve like you would solve an equation, which means I need my variables on one side and my numbers on the other. This means I'm going to subtract my 7b and bring it over here with my other variable. That gives me negative 2v, and I need to bring down the rest. Now I need to subtract my 1. I have negative 2v is greater than negative 18. At this point, I am dividing by negative 2, which means I have to now change the direction of my inequality symbol. If I multiply or divide by a negative, this symbol is reversed. So now it becomes less than 9. You have just solved your inequality. Proceed with a graph. Just simply put your number 9, okay? And then look at your symbol. This does not have a line underneath it, so that tells me that my circle is going to be open. It is pointing in this direction. It's telling you that it's less than, so you're going to shade this direction. my interval notation has to match what my graph looks like. So when I start on this side of my graph, I notice that it is going to negative infinity. That will always have a parenthesis. This side has an open circle, so it will also have a parenthesis, giving me my interval notation of a parenthesis with a negative infinity and then comma 9 with the parenthesis. Number 5. I first have to distribute my negative 2 to both of my terms in my parenthesis. This means I'm going to bring down my 12p plus 52 for my initial step and my inequality symbol. I will now have negative 8 plus 4p. Get my numbers on the same side, my variables on the same side. I'm going to start by subtracting my 4p. This gives me 8p. Bring down the rest. I need to subtract my 52. This is going to give me 8p is greater than negative 60. When I divide by 8, my p will be greater than negative, let's see, divide this by 4. Divide that by 4 is 15. Divide that by 4 is 2. Negative 15 over 2. That's the same thing as negative 7.5. So either or would be an acceptable answer. I'm going to leave mine as a fraction. All right, so now I'm coming over to my number line, and since it says it's greater than, that's an open circle. Write your number, and it's greater than, which means it's pointing this direction, and my interval notation must match what my graph is doing. Open circle means it's a parenthesis, and if it's going to positive infinity, that's also a parenthesis. So my answer will be written as parenthesis and then negative 15 over 2, comma, infinity with another parenthesis. We're not going to do set notation at the bottom on the back side, but we are going to look at some special cases. So let's start with number 7. Once more, we start by beginning to simplify with our distributive property. I will have 24x minus 27 is greater than 24x plus 4. To get my variables on the same side, I'm going to have to subtract my 24x. When I do so, both of my variables cancel out. If you recall, this is going to take me to a scenario where I have a special solution because I no longer have a variable. Bring down what's left over. Bring down the symbol for what's left over, and then ask yourself, is this a true statement? Is negative 27 greater than 4? No, it is not. For that reason, my answer is no solution. If there is no solution, there is no number line, there's no graph. Let's look at number 11. Once more, I need to distribute, but I'm not going to do anything with my 11x minus 4 on my initial step. So just bring this down, bring down this as well, and of course you bring down your 6x because what you're distributing is going to be the -1 that's right here. I will now have -3, and that will be plus 5x. All right, let's clean up what we have here. Bring down your 11x minus 4. Bring down your inequality symbol. But this will now be 6 plus 5. That gives me 11x. Bring down your minus 3. And let's get our variables on the same side. To do so, I subtract my 11x on both sides. They cancel. When your variables cancel, you bring down what's left, and then you ask yourself, is this a true statement or not? Is -4 less than or equal to -3? Well, yes, -4 is less than -3. So since that is true, that means it is infinite solutions. Infinite solutions means the same thing as all real numbers, so you can use this symbol here as well. All real numbers means the entire graph would be shaded. If my entire graph is shaded, then my interval notation needs to show that every number is a solution. My graph is going to go from -infinity to +infinity. So write that down. Just don't forget to write your parentheses. That's what goes with infinity symbols. Last problem. This has a lot going on because my first step is going to be to get rid of my fraction, and I'm going to do so by multiplying by that -2. If I multiply a -2 on both sides, this will cause me to flip my inequality symbol. It will now turn this way. And my -2 is gone, so all I have to do is bring down my 4 plus my 5 times 2w minus 10. And on this side, I have a -2 times w plus 7. Go ahead and distribute. Bring down your 4 plus 10w minus 50 is greater than -2w minus 14. Clean this up. 4 minus 50 is -46. Bring down my plus 10w, my symbol, and my other expression. I want my numbers on one side, my variables on the other. I'm going to add my 2w to bring it over here. Bring down my -46. This will be plus 12w. Bring this down. Bring down my -14. Add my 46 here. Add my 46 here. I will bring down my 12w, my greater than sign, and now I've got 46 minus 14. That's going to give me 32. So I've got 32 on this side. When you divide by 12, you are going to end up with the fractional answer. Your w is going to be greater than 8/3. So write your 8/3 with an open circle, Greater than means it goes this way. And my interval notation has to match what my graph looks like. So it's going to be a parenthesis on both sides. And I'm going to have 8 over 3, comma, positive infinity.